Hysteresis refers to a situation where the magnetic flux lacks the increase or decrease in magnetizing force. Hysteresis loss is energy wasted in the form of heat when alternating current reverses rapidly and molecular dipoles lack the magnetizing force. For steel and other hard magnetic materials, hysteresis losses are much higher than in soft magnetic materials like nickel iron. To plot the hysteresis curve, you need to have the test string in the form of a closed loop. It can be either a ring or a square form. Here we have one sample which is in the ring form, and it is made up of some laminations which are wound together using paper tape. Now we need to calculate the primary windings and the secondary windings for this sample. Primary turns are less than the number of secondary turns. So here for this sample we have 8 primary turns and 31 secondary turns. Let's connect the sample to the terminals of the machine. These are the primary terminals and these are the secondary terminals. Now I have connected the primary windings to the primary circuit and the secondary windings to the secondary circuit. The parameters that should be input to the machine to plot the hysteresis graph are density of material, mean path length, cross-sectional area of sample, along with the number of primary and secondary turns. The checking parameters such as alternating current magnitude and the frequency also needs to be specified according to the end application of the product. After we have input the basic parameters, then we can start to plot the graph. Now as you can see, the graph is being plotted slowly and gradually. Hysteresis curve is known as BH curve. On the graph, the x-axis is magnetization H and y-axis is magnetic field B or current density J. Hysteresis plotter is designed to study basic magnetic properties for magnetically soft materials.
So as you can see, this is the hysteresis plot or the hysteresis graph. On the x-axis we have J, which is the current density, and on the y-axis we have J, which is the current density, and on the x-axis we have H, which is magnetic field and strength. Yeah. So So now we get the results, which is we get the value of magnetization, coercivity, remanence, loss, effective permeability and peak permeability.
After the graph is plotted, you can save the graph in the form of a PNG file with the help of applications like Paint. Also, you can save the values that you have obtained from the graph using the options Save Results. Here you can see, as we go on increasing the current, the magnetization increases up to a certain value. After that, when the current reverses, the magnetization lags the current by some value, and when the current is zero, at that time there is a residual magnetic field left in the material, which is known as remanence. At Permanent Magnets Limited, we have a team of dedicated engineers and metallurgists to provide you with technical expertise. Thank you for watching this video.